Hi, this is Emma from Arise, and I'm here today to talk to you about astronomy in your homeschool. So, astronomy is one of these maybe one of these more geeky science disciplines. I think it's absolutely wonderful. I have always loved astronomy. As a little girl, my dad he is really knowledgeable about the night sky, and he would take me outside stargazing. He sometimes took me up to the Edinburgh Royal Observatory. I remember we went one night, they had an open night for families to go to. So it's always been something that has been part of my life since I was very, very young. I found just going out stargazing with my dad, and he'd be able to identify and tell me the names of the stars and the planets. That just absolutely fascinated me, that amid the myriad of these little points of light, he was able to identify them. He would read astronomy books to me, we would watch astronomy documentaries together. So it was a real integral part of my childhood, and that bonding between my father and myself. At university, I studied mathematical physics, and I did a year of astrophysics at that time as well. Um, it's just a discipline that has always been a source of wonder to me. And as I've grown and I continue to study all these years, I've really found that studying astronomy, studying the stars and the planets, and the science of it has actually increased my faith in God. It's just such a wonderful area of science to study. And I find with young children, there is a natural draw to astronomy. From children, they're a very young age, when you've got this little toddler and they've got that beginning of an awareness of the natural world, and they see the moon and they point up to it, point to a full moon. The beauty of that draws them. With small children, when they go out at night time in the winter, and it's not late, but it's completely dark, and they look up and they see the stars. There's that natural draw for children to engage with space and with stars. And then there's that whole other idea of that children get that fascination with space exploration, with going to the moon or traveling to the planets and spaceships and the space station. It is an area of learning that has this natural capacity to really grasp hold of a child's imagination and their wonder and their desire to learn. So I think for all those reasons, I think astronomy is a really great subject to bring into your homeschool life. Also, as Christians, I think it's good to understand the universe. As I mentioned, that as I've studied more and more, it's really given a depth to my faith. I now see in the universe this hugely precise system that's absolutely vast, but has been engineered for us to be able to live here on Earth. Many of you may have seen these kind of YouTube videos where it talks about the scale of the universe. It'll start with the Earth, and then it'll compare the size of the Earth to the size of the sun, and then the size of the sun to the next biggest star, and so on. And then it'll zoom out in ever increasing magnitudes of bigness, and then it'll zoom back in. And a lot of Christians will share these things as a way of being able to kind of have a visualization of the vastness of God. And I sometimes think that this can almost make us feel insignificant. And one of the things I've discovered in more recent studies and readings that I've been doing is that the massiveness of the cosmos actually engineers the conditions for life on Earth. So the more I've studied, even in this last year, this understanding that God has perfectly designed this massive cosmic world for us to be able to dwell, that truly the heavens declare the glory of God. Also, in the study of astronomy, we really get an idea of the history of science. So many of the great leaps forward in our understanding of how the universe works, how the world works, have come through our study of the heavens, of stars, of the planets, and how these are all interrelated, how they move in the heavens. Being able to understand the very concept of time, how 24 hours in a day is not actually 24 hours long, for example, and these very precise readings of the planetary motion, the Earth's motion around the sun, and how that affects our relationship with time itself and the seasons is really quite profound. And it has shaped us as it's shaped humanity down through the ages. We see that in ancient civilizations, for example, many of these amazing structures that people who we would discover who would be have been described in the past as uncivilized, they built amazing complex structures, and they are mirrors of what they were studying in the heavens. People like the ancient Egyptians, the Babylonians, the Mayans, all these different ancient cultures had quite sophisticated understandings of celestial systems, which is astounding given the lack of instruments, no telescopes, a limited mathematical ability and language, and yet these structures that they created, for example, the pyramids or places like Stonehenge in England, they are very precise in understanding celestial events, the motion of the sun, the earth around the sun, the motion of the moon, and it shows that these people had a great understanding of what they were seeing. They must have spent years studying the motion of the stars, the moon, the sun, to be able to gain understanding to build the structures that they ended up building. Copernicus, far later, when he was studying the stars in the heavens, and there was that kind of, in that age, there was this understanding developing that the Earth wasn't the center of the universe, that the sun was at the center of the solar system, and the planets were orbiting around the sun, not that everything were orbiting around the Earth. So that was the heliocentric model, the helios being the sun is at the center. Copernicus spent years with very early telescopes, hours and hours at night, cataloguing the motion of planets and stars in the heavens and measuring them to high degrees of accuracy. He had pages and pages of charts. And from that, he was able to build these mathematical models of how the planets were actually moving in space. Years of work, painstaking, patient work, with huge amounts of data. And I find that absolutely fascinating. As we study astronomy, we also see this interconnectedness with other scientific disciplines. I think there's something deeply wrong in the way we teach science. So I'm talking about teaching about astronomy, and your kids might do chemistry or physics or biology. However, there is such interconnectedness, which is understandable. There's interconnectedness with all these different disciplines, and we see that in astronomy. The language of all science is mathematics. You could think of mathematics as being the purest of all sciences. And we can apply mathematics to how the solar system, how the planetary systems, how the universe, how the galaxies, how all these big structures relate to each other. Truly, maths is the language of science. It is you can even think it was the language of God. God speaks in numbers to us, and we see that in mathematics, the beauty of mathematics, the symmetry, this beauty yet complexity, all points to there being a creator. But in astronomy, we also see physics. The laws of physics are outplayed on the celestial scale. We see Newton's laws of motion, of gravitation, Einstein's laws of general relativity, of special relativity. They are all so plainly obvious when you start to study astronomy, that to understand the workings of these different planetary systems, of galaxies, of how galaxies react, move in relation to other galaxies. All of these things are explained in the laws of physics, but also chemistry. The chemistry of the very elements that are in the earth, and the reactions that are in stars. We can only understand how a star works by looking at the physics of the thermonuclear reactions, but we also think about the chemistry of these elements that are being generated within the stars as a result of the thermonuclear reactions. We see the cosmic grand scale of a world controlled by gravity, of universe controlled by the gravitational pull of these massive big centers of mass, the galaxies and the black holes and all these different things that work together. There are, however, you also have the reality of the quantum world, which is so tiny compared to the world in which we're living in every day. The quantum world also has this effect on the cosmic world and stars and how they work, and all these different ideas. They're all this interconnectedness of all these different scientific disciplines are seen on the backdrop of astronomy. Also think when you're talking about astronomy is, I think as home educators, we can be astronomy can be one of these things that scare us. Same as biology when thinking about evolution, and if we don't have the language or that knowledge or that understanding ourselves to be able to speak into it, it can be something that scares us to be introducing and bringing to our kids. However, as I said, the more I've studied astronomy, it has brought a depth to my faith that is ever growing. And by studying astronomy, we can actually see that hallmarks of a creator. So I briefly want to discuss some of the ideas that we have in astronomy that really point to there being a creator. One of the first arguments for there being a creator is what's called the cosmological argument, and this basically deals with the law of causality. And the law of causality says that everything that has a beginning has a cause. And so we take that law of causality, that everything that has a beginning has a cause, and then we look at the universe, and we're looking at the evidence in the universe that would state that would show us that the universe had a beginning. Now, 100 or so years ago, the scientific community didn't believe the universe had a beginning. There was the atheistic scientists at the time. They were they were certain, they were absolutely convinced and sure and certain that the universe was eternal, that it had never had a beginning, that it had always been. Therefore, there was no beginning. So the law of causality did not apply. 100 years ago, they began to find evidence for a beginning. And this started off with in different ways, in different strands. So you had the work of Edwin Hubble, who the Hubble Space Telescope is named after. Hubble was studying galaxies, and he was mapping how galaxies move, and he found this really strong correlation that showed that the universe was expanding, that the galaxies were moving away from each other quite quickly. And the further they were away, the faster they were moving. And this is the idea that led to the Big Bang. So if things are moving away, if you wind back time, they're going to be coming closer together. Now, I think, again, this is one of these ideas that in Christian circles we're almost, oh, the Big Bang's bad. The Big Bang is one of these things in science that is very badly named. And secondly, is not, it's not like, oh, at the beginning there was a Big Bang and out of nothing everything was created and that gets rid of God from the equation. It's not that simple. So Hubble said everything is moving apart, therefore everything had to come, at one point everything was close together. And at some point there must have been a beginning. And so what I'm going to refer to as Big Bang, we could call it a creation event. So there was some point, a creation event, where everything came into being. And Genesis 1:1 says, in the beginning, God created the heavens and the earth. On day one, God created light. In the beginning, this event, this creation event was an event where pure energy, there wasn't, and then there is. We can't understand it. There's so many, even now, if you were to really look into the nitty-gritty, the maths and the ideas around Big Bang theory, it's not a theory that is cut and dry that everyone knows, has a nice answer to how it all happened and what caused it and how did we get from this point at the beginning to where we are now. That is something that we don't know. There's many huge unanswered questions within science itself. There's a lot of physics that is still needing to be done in there. They do not have a nice answer to give. So what I really want you to grasp hold of is this idea of in the beginning. This discovery turned science on its head because no longer was the universe this eternal thing that didn't need a cause to make it happen, didn't need God at the beginning. It was now something that had a beginning and therefore had a cause, all because of, well, not just because of Hubble's work, but largely because of Hubble's work in this idea of the expanding universe. The law of thermodynamics is quite a misunderstood principle. It's all to do with entropy. Entropy is to do with disorder, that systems move to a state of disorder, which is like energy that we can't, unusable energy. Energy is not created, you cannot create energy and you cannot destroy energy. The energy that is in the universe is a constant. However, there's different types of energy. For example, you can have thermal energy, you can have kinetic energy, you can have chemical energy. Now, the kinetic energy of the particles flashing and flying around the room as you're sitting in, all that kinetic energy isn't very usable. You could heat a pot of water up and on your stove, and that heat is useful energy. You're able to use it to cook with, it's useful. But as that heat from the stove is lost into the room that you're in, it gives that energy to the particles round about. You can't take the energy of those particles flying around and put it back into the stove to cook with. That is what the entropy is all about. And again, the second law of thermodynamics it's like that clock. You wind it back to a point where energy was in a more useful state. And as the universe, the timeline from the point of origins goes forward, you lose the usefulness of the energy. The expanding universe, we've talked about that. In the 50s or 60s, I can't remember, there was a team of scientists who were building a radio telescope. So this looks for radio waves in the universe that have been emitted from different stellar objects, because a star, galaxy, these different objects in the universe, they don't just emit visible light, they emit radiation from the whole spectrum of the electromagnetic spectrum, from radio waves through to infrared, visible light, ultraviolet, X-rays, microwaves, gamma rays, all these different types of radiation. They get there's a broad spectrum of different wavelengths that are emitted from all these different celestial bodies, and astronomers will build different types of telescope to analyze the different wavelengths of light that are emitted. So they built this big radio telescope and they turned it on, and they were picking up this really annoying little signal that they thought, oh, must be a glitch. So they cleaned it all, they tried to fix it, they thought it might be birds nesting on the antenna. They tried everything, but they couldn't get rid of it. And then they realized the reason they couldn't get rid of it is they were picking up a signal coming from space. And this is what we now call the cosmic microwave background radiation. And it's like a heat, but it's not very hot, it's very cold. This heat, this radiation that's been left over from the creation event of the universe. And it just is everywhere. And you'll hear people call it as like the remnant of the Big Bang, but it's almost like if you have a fire, and the further away you get from the fire, it gets colder and colder and colder, but you can still just pick up the heat from the fire. And this creation event in the universe is this kind of remnant of heat that is lingering, and it is spread. They pointed the telescopes every corner, every part of the sky, and it was there. They've now mapped this cosmic microwave background radiation, and what is amazing is that this radiation fingerprint is been described as the fingerprint of a creator, and within it we can see the points of which galaxies could form. It's like a seeding where that would enable galaxies to form and grow, and it's embedded within this cosmic microwave background radiation. And it's not this random thing. As I just said, it's been described by atheists as the fingerprint of a creator. And therefore, if they're saying that, they're seeing the hallmarks of design, that if it wasn't the way it is, galaxies could not form. There wouldn't be galaxies and there would not be life. So this again, it points to the origins, the background radiation. The other scientific theory that points to origins is general relativity. General relativity is one of Einstein's famous theorems, although this has been scientifically proven to a high degree of accuracy. And general relativity basically talks about gravity and time being interchangeable. And again, it is all about, because of the consequences of general relativity are that there has to be a point of beginning, a point of origin. So when you look at all these different points of evidence, you come to this conclusion that the universe had a beginning, therefore it had a cause. Now, there's a book by a famous astronomer by the name of Robert Jastrow. Now, Robert Jastrow is a self-professed agnostic, and he wrote this book called God and the Astronomers, and there's a line in that book which I just think is wonderful. So I'm reading from this book. I have not enough faith to be an atheist. And Jastrow wrote, "For the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He is about to conquer the highest peak. As he pulls himself over the final rock, he is greeted by a band of theologians who have been sitting there for centuries." Which I find just an amazing quote coming from this agnostic. There's also the point, so that's all about the evidence for a beginning. But that's not the only evidence that we see in astronomy when we study astronomy of the hallmarks of a creator. We've also got this whole idea of cosmological constants. So a cosmological constant is a condition that is the same as like the speed of light, for example, that but these are things that we need to be in place at a very particular degree and level that make life possible. So, for example, the level of oxygen in the Earth's atmosphere would be a cosmological constant to make life possible. And there are many, many of these cosmological constants. And the fact that they exist and they're all interrelated is also one of these hallmarks of a creator. And the more I study about these things, it just blows my mind away at the precision and the design and the elegance of the universe, how it interplays with mathematics, with chemistry, and how you see in all these different things the need for a creator. So I hope this has inspired you to introduce some form of astronomy into your homeschool life. Thank you for listening.